Okay, 13 through 22 is 7.4 stuff. So if you're struggling with 13 through 22, check your 7.4 notes, examples, homework. This is where the question is reversed. Instead of going to your unit circle and me saying, what's the sign of pi over 2, and you saying that it's 1, the reverse is, where on the unit circle is sign 1? And the answer would be pi over 2. Okay, so it's the reverse of the question. You just have to remember 1, if it's embedded within another trig function, that you always calculate the inside one first, and whatever you get then goes in place of that, and you would calculate tan of that answer second. You also have to remember, if you see a little inverse symbol, the little -1, that means that you're finding the angle, which means you've got to go to your formula sheet, come down here to the bottom, and watch your quadrants that you're allowed to pull from here and here. And also just remember that it's not really an issue, but tan in particular is open circles on those. Tan is open, but not really, it doesn't come up. Okay, so number 15 says sine inverse of -√3/2. So the question is, since it's sine inverse, what two quadrants are you focusing your attention on? You go to your formula sheet and you would find sine inverse, and the answer is that it's 1 or 4. Then from there, you say to yourself, where in quadrants 1 or 4 is the y value -√3/2? Well, since it's negative, that tells you you're in quadrant 4. And anytime the answer is coming from quadrant 4, you have to calibrate it. It's not the answer that's on the unit circle. So going to my unit circle, in quadrant 4, the y value -√3/2 is right here. Okay, so what is the radian measure? Well, is that right? 5 pi over 3. But the answer has to be calibrated in negative radians. And the way you get that is multiple ways. One way, the way I do it, is I just look for the symmetry up here in quadrant 1. 5 pi over 3, which is 300, has a reference angle of 60. So I go up here to my reference angle of 60, and I just make this -pi over 3, and that's the answer. Quadrant 4 answers always have to be negative because of the restriction on the range. The others are easier. They're exactly what it looks like on the unit circle. Quadrant 4, you have to be careful. If you had written 5 pi over 3, I would give you most of the credit. I would only take off the part, like 1 point for not calibrating it. Remember, if it is tangent, like when we start the test tomorrow, before you even start the test, I would go on your formula sheet and I would find the tan of this, and I would find the tan of this, so that is done. You don't have to do it again. It's almost like it's part of your formula sheet. And I think we came up with a stupid way to remember it. It wasn't that this one is √3/3 because it's in the front. Wasn't that it? And then this was the nice one. I think so. Is it? Why? I'm doing cotan. I was sitting there doing cotan and I'm like, no, it's not right. It's tan. So that way when you get to a tan inverse problem, you don't have to calculate it. You already got it right there. You just have to go find that coordinate point or that coordinate point in the quadrant that you're supposed to be looking in. Watch your negatives. The other thing on the formula sheet that I would probably add for me is those trig identities. You've got sine squared plus cosine squared equals 1. I might go and put that cosine squared is equal to 1 minus sine squared on there or something. Something I do remember from the last exam, it wasn't a lot of people, but I saw a couple people do this. And it was when it was simplifying or proving the trig identities, which I would probably surmise is the hardest part. I saw a lot of people changing tangent to 1 over cotan, or cotan to 1 over tan. Okay, so those are correct. Those are the correct relationships, but that's not going to help you cancel stuff out. So I would not go that route. If I see tan, my mind always goes to sine over cosine. And if I see cotan, then it's cosine over sine. I would go that route because then things can cancel. Okay? That was on a couple people's tests. The other thing is remember to get common denominators and get it to a single fraction before you keep, change, flip. You cannot keep, change, flip. For instance, if you have like something like that over, even if that's a single fraction, you can't keep, change, flip this until this is a single fraction. So be careful with that. Yes, Josh?
Do you need to do more
Okay. I worked the left to get it to the right. Have you started on the left?
Yeah.
Did you change cotan to cosine squared over sine squared?
Yeah.
Okay. On the bottom, did you change another mistake I saw a few times on the last test was if it was squared and then you substituted something else in, you forgot to put the squared. And that definitely changes it. So watch that. If it's squared, it needs to stay squared. So this was 1 over sine squared plus, right? What do you need to get on the bottom before we can do anything? Yeah, you've got to have a common denominator in the bottom. So what does the first fraction get multiplied by? So both denominators are totally different. So your common denominator is going to be both of them, right? So the left fraction needs cosine squared. So I'm going to multiply this by cosine squared over cosine squared. And the right fraction needs sine squared. I haven't done anything to the top. Bottom, now going straight across, I'm going to have one fraction. I can see that times 1 does nothing, so that's cosine squared plus sine squared. All over the denominator that we just said they have in common. Red means wrong here. Can I do this?
No.
No. The top is attached with that plus sign. That's a binomial. That's a monomial on bottom. You can't cancel a monomial into a binomial unless what you're canceling is in every single term of the binomial. So if I'm trying to cancel sine squared from the bottom, it has to come out of both terms in the binomial, and it can't, so be careful there. But what is cosine squared plus sine squared? 1. So I could either rewrite this whole thing or take this right here and change that to a 1, right? Now, if it were me on my paper, I would put like parentheses around this, and next to it, I would write that it's equal to 1, and I would go ahead and keep change flip now, but with that 1 in mind. So, keep change flip. Flip, that comes to the top, right? And on the bottom, I'm going to write it in green so you know where it came from. Now there's no more plus signs, there's no more like multiple terms. Now it's a monomial, monomial times a monomial, monomial. So it's fair game on what can cancel. What cancels? Yeah, that matches that completely. And what's cosine squared times cosine squared? The right hand side. Does that make sense? So this would be, I've run out of room, which is the right hand side. I think she had, yeah.
You know the 31.
31's that one yesterday. I think I said I worked both sides. Or no, I worked the left side, but the right hand side was a double angle, and so I went to it first to see what is the right hand side. So I guess you could say you worked both sides. It's up to you to do. So the right hand side is 1 over tan 2x. What is the double angle formula for tan? 2 tan over what? I don't remember. Tan over 1 minus tan squared, okay. Okay, so this is a keep, change, flip. I swear it looks like I'm spelling a bad word backwards. You get this, right? So that's the right-hand side, and I don't want to try to clean that up because I can clearly tell over here on the left-hand side there's a mess. So I'm just gonna, in my mind, I'm thinking, okay, I'm just gonna hold off on that. I'm gonna go to the left-hand side now, and see what's going on here. Okay, so the first thing I notice is I have a 1 minus tan squared in both of my expressions, which is nice, right? Then I have a 2 here and a 2 here, so that checks out to be good. Then I have a cotan in the top. Over here I have a tan in the bottom. Okay. Let's come right here. I know I just just said when you see tan, don't replace it with 1 over cotan, but in this particular instance, since you see a cotan and a tan here, this is actually the route you go. What is tan? It's 1 over cotan, and what's cotan? 1 over tan, right? Okay, so right here, you see how that's cotan? What is that? 1 over 10. So I'm going to highlight this to show you that that is actually 1 over 10. I'm putting a dot to show that I've just pulled it to the front because it was attached by multiplication. You can do that. You can separate with the multiplication because when you multiply together, they just shove together, right? Like x squared over, say, 2. I would do 2. I said 4. X squared is just x times x, right? Okay, so cotan times this mess is just cotan times this mess, right? So I'm just putting a space to show you where I'm substituting. You don't have to. You could just go straight from here to this. No, it already has a 2.
But the cotan's in the top of the fraction, and it's still technically being.
It is. It's still over 2. I pulled it over here to the front. See how the 2 is still here? If you throw another 2 in there and then you multiply together, that's 4. You're thinking of adding and subtracting fractions. When you separate them, you have to have your common denominators. But this is just multiplying.
I think they're saying that 1 minus tan squared over tan x over 2. I think is what they're saying. Doing the 1 minus tan squared times cotan and putting 2 under all of that.
So that I've got my 2 right here, right? Where it started? Okay. This green is 1 over 10. It would be the equivalent of me writing it like this. I shoved in there. I showed you, I wanted to show you that I changed cotan to 1 over 10. But because it's all within one fraction and this is multiplication and this is multiplication, you can show the fraction like in the front and then just multiply it back in. Does that make sense? You're changing the cotan to 1 over 10. But because it's embedded within a fraction, it's the equivalent of 1 over 10 times the fraction that it's embedded within. It's like having a leading coefficient. So if this was like the leading coefficient, but I substituted its reciprocal function in, and then multiplied it back in. If I threw a tan in here, are you saying there should be a 2? A 2?
I'm saying that and 1 over 10x should be like in the top of the fraction. Like with the 1 minus 10.
If you put it in the top of the fraction and then you keep change flip, it's still going to end up right where it is. Because in the top, remember, top of our keep change flip stays the same. Because the cotan's in the top, it would be part of the keep. So if I wrote it as 1 over 10 right here, and then went about keep change flip, what's going to happen is the 2 is going to become a 1/2, which means it ends up right back in the bottom next to the tan.
So it doesn't matter anymore.
If since the cotan's in the top, it doesn't matter. So I took out the keep change flip because it's not going to change anything. So this is one of the, and then now these match. Reagan, what number? 21? Okay. 10, fraction, or, can't talk. A function within a function. Okay, so remember, we said do the inside one first. Right? Secant. You can't look at your unit circle and find the secant value, so change it to the reciprocal. So instead of evaluating secant of pi, I can evaluate cosine of 1 over pi, right? Or 1 over cosine pi. I can't find secant of pi, but I can do 1 over cosine pi. And before you go looking on your unit circle for that, you need to evaluate it and keep change flip. So what is cosine pi? This is regular trig, by the way. There's no little -1 in the exponent position. So this means just go to your unit circle and find the x-coordinate of pi. And what is it? -1. So I'm going to substitute right here that that's -1. And that, of course, is -1. So this is now tan inverse of -1. Remember, the quadrants at the bottom of your formula sheet are telling you which ones you're allowed to pull from. Tan runs from 90 to -90. And with tan being a negative, that means you're in quadrant 4, and it's -1, which means it's that pi over 4 reference angle. And so it would be negative pi over 4, which is the answer. So it's like a scavenger hunt. Those questions are. The only ones you have to be careful on are if it has the little -1. Watch out. If it's GPS, watch out. If it's a regular trig function, then you're just looking at your unit circle. If it's a reciprocal function, rewrite it as a regular function, like number 20 has cosecant right here. Of course, you have to evaluate sine inverse first. But once you evaluate sine inverse, which it ends up being pi over 6. So this ends up being cosecant of pi over 6. You can't find that on the unit circle, so change it to 1 over sine pi over 6. And then find sine pi over 6. Sine means the y-coordinate. The y-coordinate at pi over 6 is what? 1/2. And if I keep changing that, I end up with 2. Also remember, I think, on 13 through 22, you can type those in your calculator. You do need to be in radian mode if you are typing in a pi. But you can type those in your calculator and get the exact decimal value. And then when you come to your answer, type your answer in the calculator and the decimals should match. So then you know if you did it right or not. And some of them are not. Like this one ended up being 2. So if you type that whole thing in, your calculator is going to say 2. However, you need to be able to show me your thought process. So on the front, because that was the new stuff, we already went over 1 through 4. On 5 through 12, did anyone have any questions? Like the first 4 were easing into it, and then the last 4 involved square roots or factoring. And one of them had substitution. Number 11, I worked 11 yesterday. 11 had substitution because you had sine squared in there with a bunch of cosines, and that's hard to evaluate when they don't match. Let's see. I'll print this one. Number 12 has, hold on. Number 12 has some double angles in here. There's one here and here. You can't do anything with this until you get rid of those double angles, so you're definitely using substitution there. And it's sine double angle, which means there's only one formula to plug in. Remember on those, if it's really confusing, change cosine to x and sine to y, and then you might be able to see the algebra 2 that's embedded within it, and then just do your algebra 2 steps. Does anyone have any more questions?